Okay, so the next talk is a context-based framework for modeling the role and function of online resource citations in scientific literature, presented by He Zhao.
Thank you for the introduction. So this is Zhao He from Beijing Institute of Technology, and I'm so glad to introduce our work, context-based framework for modeling the role and function of online resource citations in scientific literature. So with the number of scientific publications growing dramatically, we can find that more and more scientific online resources are mentioned, released, and used in scientific literature. So like the WordNet is always the data, and the Lucene is always the tool, and the Google Translation is sometimes a website or service. So tracing and modeling these scientific results are very important and will be helpful for researchers in to build resource searching and recommendation systems, or just construct scientific knowledge graphs. So. In this paper, we propose a novel task to model the resource role and the resource function for online resource citations in scientific literature. So first, we'll give some definitions. Okay, so first, it is the resource citation. The resource citation is a hyperlink mentioned in the scientific paper text, and it will link to a specific online resource. So we found that there are two types of the resource citations. One is always in the body text, and we call that it is the inline resource citation, and the other is it's always in the footnotes, and we call that it is the additional resource citation. So you must want to know what is the resource context. The resource context, we think it is the word sequence surrounding the resource citation, and we set the context window is set to 5. It means that only 5 sentences around the citation will be considered. So that's the resource role. Here we define that it is the resource class, which indicates that what role the resource will play in its context, sometimes like the code, data, media, and so on. So the resource function is the purpose of citing the resource in its current paper context, which indicates why the author cites the resource here, sometimes like the use, produce, or compare, and so on. So in this paper, we propose a context-based framework to jointly model the resource role and the resource function. First, we introduce a new annotation scheme which can jointly model the general role types, fine-grained role types, and the function types. And then we collect and construct a new data set which is called the Sunrise for fine-grained scientific resource modeling, which the data set contains more than 3,000 manually annotated resource citations. And then we developed the Sunrise classifier, which is a multitask classification framework, and it can jointly classify the role types and the function types when we are given the resource context. Then we propose practical application, which is, and we design a sign rest recommender, which is a framework for a context-based resource recommendation task. And it can predict resource hyperlink when we are given the masked resource context. So let me first introduce our SunRest datasets. We use the scientific literature from 3 different sources. The first is the ACL Oncology Reference Corpus, which is also called ARC. And the second is the NeuroIPS proceeding, the paper from the NeuroIPS proceedings. And the third is the publications from the PubMed, which is a biomedical retrieval system. And then for the data preprocessing, we first perform OCR, and then we extract the hyperlinks and the contexts. Then for the annotation, we randomly chose 1,100 data samples from each data source, and then the annotation is performed by 3 annotators, and then the annotators are asked to assign role and function labels for each resource context. So finally, we got 3,088 data samples for both training and testing. So then let me introduce our resource annotation scheme. So we proposed 2-level hierarchical, we define the resource role from a 2-level hierarchical perspective. We first define 3 general, also called the first category role types, which such as the material, method, and the supplement. And then under the general types, we further define 9 fine-grained, also called the second category role types, including the data, tool, code, algorithm, documents, website, paper, and license, and media. And then for the function types, we define 6 different types, which includes the use, produce, introduce, extend, compare, and other. So then we describe our role and function classification task. Most of the previous work have well studied the task like the citation, function classification, and some context-based citation recommendation tasks, while few previous works have focused on online resource citations. So, and they have not identified the role and function types on such a fine-grained level, so that as the example shows in this sentence, this context, when we are given such a context, we are asked to identify the general role is the method, and the fine-grained role, like the tool, and the function here is the use. So there are many challenges making this text not so easy, such as how to pass, encode, and model the resource citation context. And from our findings, we can find that the relative position of words and the citations are very important for this problem. And then due to the limited labeled data, so some neural-based models cannot feel well. So we propose our classification model, which we call this the SunRest classifier. It is a multi-task learning framework to jointly classify the first category role types, the second category role types, and the function types. And then it uses pre-transport model to learn contextualized representations. Then it can share the resource context representation as a classification feature between the 3 subtasks. So this is the general architecture of our sunrise classification model. So we first use the pre-transport model to learn representations of each context, each resource context. Then we build three different classifiers for the three sub classification tasks, and so that the total loss is a weighted sum of the three parts, so that in this manner the whole model can be trained in a multitask process. So then, to give a practical application of our annotation scheme and our sunrise classifier, we propose a resource recommendation task where we use the context about an indexed resource as a query, and then the objective is to break the hyperlink of possible online resources to fill the context blank of a resource context. And so in this example, the input is the resource context word sequence, and here the placeholder URL is for the resource hyperlink is. It is the placeholder is for the resource hyperlink to be predicted, and then we mask the resource name in this context. So the output will be a ranking list containing the top n possible predictions from the target hyperlink space. So this is the recommendation model. Same as the classifier, we also use the resource context representations from the pre-transport model, and then we use the labels from the classification model as the features input of this recommender, so that it means that the context representation vectors and the first row feature vectors, second row feature vectors, and function feature vectors are used as the input of the classifier. So the representations are mapped into the predicted link space. So this is the experimental setup for data size to test our classifier. We just use our sunrise data set, and to test the recommendation model, for training sets we use all resource context and citation hyperlinks from ARC data sets, and for test we use the resource context from ACL 2016, ACL 2017. EMNLP 2016, EMNLP 2017 too, and then we select the ones of which the hyperlink exists in the space. So then we choose several baselines to compare our classification models. We use some widely used models which for the text classification, and to compare the recommendation models, we just use the random forest classifier. So this is the classification results. We can find that our classifier outperforms other classifiers for the three subtexts, and we can find that the multi-text learning really helps to combine information from row and the function, and by the help of the pre-transport model, it can overcome the limited training data problem, and we can learn better context representations. So this is the recommender results, and we can find that our sunrise recommender framework really significantly outperformed the other two baselines. So we also did feature ablations, and we can find that all feature components contributes to the recommendation model, and the role and function information is very helpful for understanding the scientific resource. So we also did a resource function evolution analysis to study the scientific resource development by resource function changing. We apply our classifier to the ACL ontology reference corpus, and we can find that resource will go into its maturity stage when it has been widely used in 4 to 5 years, and one resource may be out of date and or replaced by other more novel resource, maybe in 8 to 9 years. Okay, so our contributions can be summarized. So first, we propose a novel task to model the role and function for an online resource citation in scientific literature, and then we propose an annotation scheme for general role type, for fine-grained role type, and for functions. And then we collect and construct a sunrise data set. Then we develop sunrise classifier and develop a sunrise recommender. So that's all of our work. So the annotated data set and the source code is publicly available at the GitHub. Okay, that's all of my presentation. Thank you all.
Okay, well, we have time for one very quick question.
Yeah, can you go back to the GitHub page so that some of us can get that one a little quick?
GitHub page?
Yeah, good, thanks. I really like seeing these resources. When you mentioned PubMed, you said you only had 7,000 papers, but I thought there's like 30 million abstracts there. So did you use some subset of that?
Yeah, we randomly select some data samples to annotate. We don't use the whole PubMed data set because it's not so easy to label the data, so we don't use them all.
No, but when you said the population, you said there were 7,000, and you randomly selected 1,000. But there's 30 million abstracts in PubMed.
Can you repeat?
Okay. Can you go to slide 9?
Slide 9, okay. Yeah, that's the line.
Right, so here it says PubMed is 11,000 papers.
Yeah.
But there are 30 million abstracts in PubMed.
30 million abstract. Yeah, we randomly select you means that we don't use all of the PubMed abstracts. So we show here the 11,000 more than 11,000 papers. Yeah, we don't use them all. We just randomly select a part, a subset to label, to give some labels.
What's the label? Maybe we can take this offline. We should move on. Let's start the speaker again.